Hey there my fellow intellectuals, welcome back to my channel. My name is Kyle. I'm currently in the process of moving apartments down the street that way, so not a huge move, but still nonetheless I have to pack up some things. And one of the main things that I'm moving right now are my textbooks. Now, as you know, I'm a graduate student in physics at the University of California, Irvine, so over the years I've amassed a lot of textbooks. I generally like to keep my textbooks. I don't really like to give them away. I just like having vast sums of knowledge right by me. But with that comes the issue of storage space, and I'm currently running out of that in my apartment. So I decided, well, the department gave me a bookcase in my office that's not that big, but still a place to store some books. So I thought, let's move my books into the bookshelf in my office. So that's what I'm currently doing. I've already done that for a few of the books, but I still have a majority of them in my apartment. So as you can see, on the floor right there, there are some of them. And I thought it might be cool to just talk about them a bit, maybe go through some of the books, talk about how I got them, what they're about, if I can talk about any sort of cool fun facts about them. And yeah, that was pretty much my idea. I thought maybe this will help release some of the stress of the move, so let's get to it. Okay, so I'm on the floor of my apartment now, and I got a ton of these books in front of me, so I'm just going to pull them up and we're going to talk about them. So, this one. So this one is Theoretical Physics by, I guess that's Jorg Uss. This is a pretty interesting book. It's a theoretical physics book. It's just a really detailed and comprehensive book on all the sort of things you need to know in theoretical physics. This was written back, I think, in the 60s, if I'm not mistaken. But the really cool fun fact about this book is that it was like the first book I saw on Amazon when I first took a physics class in college. I essentially wanted to go and look at theoretical physics because I wanted to do theoretical physics at the time. At least I thought I did. And I wanted to find a good theoretical physics book. So I saw this on Amazon for $5 and I bought it. And I couldn't really understand a lot of it at the time. I had just taken like the very, very first physics class you take in college, and this was just way, way, way over my head. So we're talking like advanced classical mechanics in here, advanced electromagnetism, relativistic mechanics. What else we got here? We have quantum stuff. I think we have fluids in here, optics, just so much stuff. Statistical mechanics, just so much in here. So I just spent a whole minute on that one, so hopefully I won't spend too much time on each one of these. This was also another one of those books that I bought right after my first physics class. So this was Mathematical Physics. I thought the title was cool. I think it was only like $7. And again, just really too advanced for my first year college brain to really take in and acknowledge. Now that I look at it now, it's like, okay, yeah, I know this stuff. This is standard, mathematical physics that I've seen now through both undergrad and graduate physics. But still, it was a very, I guess, impulsive purchase, if you will, because obviously I just was not ready at the time, probably by at least 2 or 3 years for this book and the Jorg Uss book itself. So, two really good classic books, I think, that I still like to look through. They use CGS units, which is, CGS units is CGS units, which we don't really use too much in physics these days, but still, still good to have. This one is Lectures on Quantum Mechanics by Gordon Baim. I kind of like this typewriter font. I didn't really show that in the other two books, but they kind of have this like typewriter font that I don't know if you can see. Has some cool pictures here. I think that's an infinite square well. Looks like it. I'm not so sure. Or no, that's potential. That's a finite potential square well. My bad. But this was the standard quantum mechanics book in my graduate class that my professor really liked. So we used this through the first quarter of quantum mechanics in graduate school. Baim actually is still alive, and I believe he was a student of Julian Schwinger, who is a very famous theoretical physicist that won the Nobel Prize with Richard Feynman, and I think Tomonaga, if I'm not mistaken. Sorry, there was a third person who I believe is Japanese, and I don't really exactly remember who that was. Ooh, next one is the international edition of Complex Variables and Applications. I don't know if you can see that. Hopefully it will focus right here. Complex Variables and Applications. This is by James Brown and Ruel Churchill. Now, this book is on complex variables applications like the name suggests, but this is the book that I learned complex analysis from for the very first time. And the Brown and Churchill book is like the standard, I think, complex variables and applications book. I was talking to a professor in the UCI department about 2 years ago, and he said that he used this book, and he was an older guy, or he is an older guy, who probably took this class in the 70s, maybe. And he said that they were using, I don't know, the third or the second edition of this book. So this is like a standard now. This is the 8th edition. I think there is now a 9th edition, and maybe even a 10th edition, for all I know. So really good complex analysis and variables books. I really like complex variables because it's complex. Well, no duh, but it just has these really cool things like residues and contour integration, where you can just integrate over these like poles and singularities in the complex plane. It's really too much to really get into right now since we're just talking about the books, but nonetheless, I think it's a good book. I really like complex analysis, I have to say. It's like one of my favorite math subjects. It's just so cool. I love seeing all the different ways of manipulating mathematical stuff in the complex plane. Let's go over here. This one is Intro to Statistical Thermodynamics by Terrell L. Hill. This is an older book on statistical thermodynamics. I got this in graduate school to help supplement my class in statistical mechanics when I was taking it. I'm going to admit it right now, statistical mechanics and thermo are probably my worst physics subjects by far. I know I passed my comprehensive examinations, but still, like, this subject, it just confuses me to this day. But I do really like this book. It really talks to you in a very, how do I say, just explanatory manner. It doesn't try to rub it in your face that you don't know something, like some books might try and do. But this book is really good at teaching statistical mechanics and helping you get a really good conceptual understanding of it. And it was written by a chemist, so it has more of a chemistry, I should say, focus. So there's a lot of applications on like molecules, gases, liquids, polymers, all those sorts of things that chemists probably would focus a little bit more on than physicists, unless they're like in condensed matter or something. And I just see here the hyperbolic cotangent function. Look at that. Look at that hyperbolic cotangent. Like, where is that? It's like right there. When was the last time you got to do that, or you got to use that? I hope you can see that, like, because I'm looking at my camera right now and it has it backwards, as in like mirror imaged, but I really hope that you can actually see the coth function right there. Focus, please. Right there. Okay, moving on. Ooh, yes, this one. Mathematics of Classical and Quantum Physics. So this is by Fred Byron Jr. and Robert Fuller, or sorry, Frederick Byron. And this book I got for like 20 bucks about 2 years ago because I really wanted to up my math game in physics in graduate school, because honestly I really love math, and I love physics too, of course, but math is the thing that really, I don't know, helps you understand physics, right, in a way that it helps you learn more physics concepts, I guess in at least a mathematical sense. Then the physical sense has to come later, but to me, I typically will learn the math and then I let the physics sort of come to me after that. Which, I don't know, it all depends on who you are. Some people think it should be the other way around, where you're guided by physical principles, then you try and use mathematical reasoning to reach those conclusions. But I'm a little bit more of, I start with the math, and then, the physics supplements it. And that's why I really love physics, because it makes use of math, and, it's just this big cycle. I mean, why not love physics and math? They're all, great. Man, at this rate, whew, I don't know how long we're going to be here, but it's going to be an adventure going through all these books. Next up, we got Quantum Mechanics by Nuruddin Zitili. Now, this one is the quantum mechanics book I wish I had. I didn't get this book until I was done with my quantum mechanics education in both undergrad and grad school. And this is like the book I wish I always had and knew about, but didn't know about. So if you're taking quantum mechanics, for undergrad or grad school, and you have to take more classes in it, make sure to get this book. It is not only a textbook, it's also a problem book. So it has worked out problems all throughout the book that the author will go step by step with you, and then he'll also have the exercises at the end. But there's so many problems that are worked out for you in this book on different, subjects in standard quantum mechanics that you just gotta get this book. That's how you learn quantum mechanics. You do a ton of problems, and then it sort of comes to you. And I say sort of because it's so counterintuitive that even when you do a lot of problems, you can still get into these mind traps where you're still not thinking quantumly. You're thinking, or quantumly, is that an adjective? I don't know. But you're thinking classically. So, yeah. But remember to just do a ton of problems and get this book. It was only like, I don't know, the international edition cost me, I think, less than $30 on Amazon. So if you can get it, get it. All right. Next up, Radiative Processes in Astrophysics by Rybicki and Lightman. Now this is the standard Radiative Processes book that you find in most astrophysics graduate courses. So when you're learning about radiation and the radiation that happens in space, so we're talking like Bremsstrahlung, we're talking about synchrotron radiation, maybe Compton scattering, all of those kinds of topics. This is like the standard classic reference on it. It was written by like I said, Rybicki and Lightman. Alan Lightman, actually, this guy right here, I didn't know this, but I looked it up, and he was a doctoral student of Kip Thorne at Caltech. So that's really cool. I did not know that, and I looked, and Kip Thorne has advised a lot more people that I didn't realize he advised, and I was like, wow, that makes sense though, that he's advised other great physicists too. Okay, so what do we got over here? Let's maybe move some books here. Oh, okay. This might be a controversial one, but I'm going to pull up General Chemistry by Linus Pauling. Now, Linus Pauling was a Nobel Prize winning chemist back in the day, and this is just a really standard general chemistry textbook. So if you've taken general chemistry in college or high school, then you've definitely seen the topics in this book. So we're talking like atomic structure, periodic table of elements, Avogadro's number, quantum mechanics. So this book is cool. Sorry, I didn't mean to get sidetracked, but this book is cool because Pauling doesn't shy away from the physics at all. There's so much physics in chemistry, right? But of course, because things are happening at the atomic and molecular level, that there's obviously physics there. But like the first section of this book, he talks about mass and energy and talks about the Einstein E equals mc squared equation and how energy and mass are related to each other. And when a chemistry book starts with Einstein, I think that's going to be a good book. That's just my personal opinion because I just love physics so much. And so this book really does a good job of explaining the whys of why things happen. That didn't seem to make a lot of sense. Sorry, I'm getting tongue twisted, but I'm just really into this. So I see a lot of spectrographs, I see experiments, I see lots of tables of different chemicals and stuff. So here's like a table of chemicals. Yeah. Oh, there's graphite and diamond in there. Interesting. This is a book that I pretty much will refer to if I need to know anything about general chemistry. This is the book I have, the one book that I have really that could help me out with that subject. So thank you, Linus Pauling. So I'm going to go over here, grab some books that I may have not looked at over here. Ooh, there we go. All right. So this next one is Partial Differential Equations for Scientists and Engineers. This is by Stanley J. Farlow. And I think I got this book because I was looking on Amazon with a friend, and he really wanted to get this book for some reason. I think he wanted to understand PDEs. We were both physics majors, and he just really loved math. He really loved math, maybe even more than I did. But he wanted to know PDEs better, and this book is all about PDEs. And it's nice because this book goes through these sort of lessons. So as you see right here, it says like lesson 4. Can't read that backwards. It says derivation of the heat equation. And each chapter or lesson is just a short little, lesson that you can go through relatively quickly. So it's sort of a good self-study book in a sense, because you can just go, certain lessons at a time. You don't have to go in order. You can just, they're all sort of self-contained lessons. So really good for learning PDEs. I've definitely used this book to help me study when I took my PDE class in undergrad. And I think the fun fact about this book is I think this is this was the book that came to me like the fastest through Amazon, like the absolute fastest. I remember ordering it like on I want to say a Friday, and then like a Friday afternoon, and by Saturday afternoon I had it. And I think I just said 2-day shipping with Amazon Prime, but it got to me in one day on a weekend, no less. And I don't even know how, because I was in the middle of nowhere, Merced. Sorry, Merced, but let's be honest, you are in the middle of nowhere, California. But you're on your way to Yosemite, so that's the thing. But yeah, somehow they got to me in Merced within 24 hours, which I found very impressive. Good job, Amazon. Very good job. All right, so what else do we got here? Okay. Oh, here's a good one. So this is a book I wanted for a while, and I sort of debated whether I should get it or not. I always wanted to get it. I had heard so many good things about it, and when I learned I was going to be TAing a class that covered this subject, that gave me the excuse to make the purchase on Amazon. And what book is it, you might ask? It is Electricity and Magnetism by David Morin and Edward Purcell. So Edward Purcell was a Nobel Prize winning physicist who got the Nobel Prize for NMR, nuclear magnetic resonance, back in, I think, 1952, if I'm not mistaken, if I'm not getting my dates crossed up. And he worked, I think, at Harvard, if I'm not mistaken. So he was obviously a great physicist, but also a really good teacher, and his E&M books were the standard for many top universities' physics programs. Unfortunately, there was a change in the unit system, like I've talked a little bit about earlier, how his books, the prior two editions, the first and second edition of this book, were in CGS units, but then physics departments making a transition to SI units back in, I think, the 1980s or maybe the 1990s. I don't exactly remember, because I obviously wasn't taking physics at the time. But the other author, David Morin, who I have a lot of other books from him too, he came in and was like, I want to update this book. I want to put it in SI units and preserve the legacy that Ed Purcell created. So David Morin took it upon himself to go through the book, rewrite sections to make sure all the equations were in SI units as opposed to CGS, so it could be more accessible to the current physics student of the current day. So I bought this book because I was seeing a class that went through electromagnetism, and I really wanted to know, well, I mean, I already knew electricity and magnetism, but I wanted a new book with a fresh new perspective that focused solely on E&M, and I wanted to have some problems that I could pose to my class, and hopefully that would help them develop their own understanding of E&M. I also really like that this book has really big margins on the sides. So if you look on the margins here, there are, they have really large margins, so you can see my writing on the side, like right here. So yeah, this is a really good book, really great for understanding E&M, and I think it does a great job of helping you get a conceptual, firm understanding of the subject. In addition to a mathematical approach, though, it does, I think, shy a little bit away from really hard mathematical problems. A lot of the problems that seem really hard just require you to have a really good sense of geometry and seeing patterns, essentially. A lot of the E&M problems rely on the use of symmetry, or just having you be able to deconstruct the geometry of the charge configuration. So, yeah. And wow, look at us. We are chugging along right here. We've got a lot of more books to go, and I've already been here for almost 20 minutes. So let's see. Maybe we just go through a few more. I know it's been fun, but fortunately we don't have all day. At least I don't have all day. I got to move a lot of this stuff. So, this one. Yeah, let's get this one, and maybe a few more after that. So this one is none other than Thermodynamics by Enrico Fermi, the great Enrico Fermi. This is a book that I believe was spawned from a class he taught at Columbia back in the 30s. I forget, I can look at the exact date here. It says, this book originated in a course of lectures held at Columbia during the summer session of 1936. So we're talking like almost, wow, it's 2019 right now, so we're like 83 years ago. Jeez, I hope I did my math right there. But nonetheless, sorry, I am like doing the math in my head right now, and I can't seem to, oh, is it 36? Yeah, okay, I guess it's 83. What did I say, 83, 86? I can't remember. Anyways, moving on. Yeah, this book I bought to help me understand thermodynamics better because, like I said, thermo was probably my worst physics subject, even after all the classes I've taken in it, and by all the classes I mean like 2 classes in it, undergrad and grad combined. But nonetheless, thermo was actually one of my favorite subjects in high school when I was taking chemistry. There were a lot of cool things I didn't really understand, like entropy, right? Entropy was a weird concept in high school that the high school teachers really couldn't explain fully to us, in the sense that they weren't, it's not that they weren't smart enough, but like they didn't think we would be able to handle the answer or really understand it, and which makes sense. Entropy is a very complicated concept. So yeah, entropy, enthalpy, Gibbs free energy, all that stuff was really fascinating to me in high school. The concept of absolute zero, and classically all motion stopping at absolute zero, and how cold it is. But for some reason I just ended up growing out of that phase. I think thermo was cool for a little bit in high school, and then when I came to college I think quantum took over as like the cool thing, because quantum is still like my favorite core physics subject, I think, by a lot, more so than classical or E&M. So yeah, let's start this book. It's really short. It's only like 150 pages. So if you need to get a quick refresher on thermodynamics taught by one of the greatest physicists of the 20th century, yeah, I picked this up. It was only like $7 on Amazon, so good purchase there. All right, so I think that we only have enough time for maybe 1 or 2 more books, and I'm trying to decide what's a good one here to show you guys. Oh, jeez. Okay, so I'm going to go ahead and show off this one as the last book for now, before I move everything into my office. This one is Introduction to Classical Mechanics with Problems and Solutions, and this is by none other than David Morin, who I mentioned earlier. And again, this is a book that focuses on classical mechanics, but like Noordean Zitili's quantum mechanics book, it has a ton of problems. Just so many problems for you to do and understand classical mechanics better. And this is the book that when I was tutoring students in classical mechanics, I would pull problems from this book, and we would go through the problems together. Well, I make them do it, and then we would sort of reconvene and see how they approach these problems. He's really good at giving tricky problems that are not hard, but you kind of just need to see them. Some people may not like that, and I can understand why. But nonetheless, there's a lot of problems for you to do, a lot of good examples worked out on mechanics, Lagrangian and Hamilton. Actually, no, this is mainly a Lagrangian mechanics book. Hamiltonians I don't think are in this book. But I think he wrote a supplemental chapter that's on his website that's on Hamiltonian mechanics. So yeah, another good classical mechanics book to add to your shelf if you've got like Taylor on there already, or if you've got what's that one, Marion and Thornton on your shelf already. This is definitely a good addition to bolstering your classical mechanics understanding. So with that, I feel like it's getting later in the afternoon and I should move this stuff sooner rather than later, so I think I'll stop talking about the books now. But nonetheless, I really hope that you enjoyed this video. I hope that it was interesting to see all my books and you appreciated me just babbling about books for nearly 25 minutes or so. So I will be packing up and I will be heading to move these books into my office, and maybe I'll take you guys along. So stay tuned for the future.